Hello everyone, I am Tejashree. I am studying BTech second year ECE in SRIT College, Anantapur. My roll number is 234Z1A04B6. Today my topic is comparison of PAM, PWM and PPM. From the subject Analog and Digital Communications, the subject code is 23ECE403. Comparison of PAM, PWM and PPM. Differences in performance, bandwidth and noise immunity. Introduction to PAM, PWM and PPM. Pulse amplitude modulation, that means PAM. Pulse width modulation means PWM. And pulse position modulation means PPM are the three techniques used in signal transmission. Each module techniques has its own unique characteristics and application. Understanding these differences is crucial for selecting the appropriate method for specific communication needs. Here you can see the modulating signal and PWM signal and PPM signal. Overview of PAM. PAM encodes information in the amplitude of pulse signals, allowing for multiple levels of signal representation. The bandwidth requirement for PAM increases with the number of amplitude levels used. PAM is sensitive to noise, which can distort the amplitude levels and lead to signal degradation. Here you can see the waveform of PAM. Here you can see the amplitude and the frequency. And overview of PWM. PWM encodes information in the width of the pulses, where the duration of the pulse indicates the signal level. This method is known as for its effective power control and efficient transmission across various applications. PWM exhibits better noise community compared to PAM, as variations in pulse width are the less unsusceptible to amplitude noise. Here you can see the what is PWM. Observe the waveforms in the picture. Overview of PPM. PPM encodes data by varying the position of a pulse within a fixed time frame, representing information through time intervals. The bandwidth of PPM is generally larger than that of PAM and PWM due to the need for precise timing information. PPM offers high noise immunity, as changes in pulse timing are less affected by amplitude fluctuations. Performance comparison. PAM performance can degrade significantly in noisy environments due to its reliance on amplitude levels. PWM shows good performance in power applications, especially in motor control and signal transmission. PPM is particularly effective in systems where timing is critical, such as GPS and wireless communication. Here you can see the complete course digital communication performance comparison of PAM and PWM and PPM. Bandwidth considerations. PAM requires a wider bandwidth when using multiple amplitude levels, which can lead to spectrum inefficiency. PWM typically requires less bandwidth than PAM for similar information transfer, making it more efficient in certain applications. PPM demands the highest bandwidth due to the need for precise timing and synchronization of pulses. Here you can see the waveforms and the bandwidth. Observe the bandwidth between them. Noise community of PAM. PAM is vulnerable to noise, particularly amplitude variations, which can lead to errors in signal interpretation. In high noise environments, PAM may require additional error correction and techniques to maintain signal integrity. The reliance and amplitude makes PAM less suitable for long distance transmission without amplification. Noise margin and noise immunity. Noise immunity of a logic circuit refers to the circuit's ability to tolerate noise voltages on its inputs. A quantity measure of noise immunity is called noise margin. Here you can see the high level and low level noise margins. Noise immunity of PWM. PWM enjoys improved noise immunity compared to PAM due to its use of pulse width rather than amplitude. Variations in pulse width are less likely to be misinterpreted by receivers in the presence of noise. PWM's resistance to noise makes it a popular choice in industrial applications and audio signal processing. Here, observe the noise in PWM. Noise immunity of PPM. PPM is highly immune to noise as it encodes data based on pulse position rather than amplitude. This characteristic allows PPM to maintain signal integrity even in challenging transmission environments. PPM's robustness against noise makes it suitable for critical applications such as satellite communication. Here you can see the noise margin and noise immunity. Conclusion and applications. The choice between PAM, PWM and PPM depends on the specific requirements of bandwidth, performance and noise immunity. PAM is often used in applications requiring simple amplitude-based signaling, while PWM excels in power efficiency. PPM is preferred in sceneries where timing precision is paramount, exemplifying its use in modern communication systems. Thank you. Thank you for watching this video.